We talk about reverse shells a lot. We know that they're a hacker's best friend, but how do they actually work? Well, today, you're going to find out. Here we are in the infamous Kali Linux, and I've already created a malicious payload with a pretty popular rat generator that can be found on GitHub. So this is some straight up script kiddie malware, but that's fine, because most attacks are done by skids anyway, and even this crap is going to be able to bypass Windows Defender, as I'll show you right now. So here we are in a Windows 11 VM that's fully updated, and if I open up the Windows Security tab here, you can see that everything is set up. And the only thing that it's really complaining about in the Virus and Threat Protection tab is that it wants me to set up OneDrive for file recovery. So, Microsoft wants me to do this to, I guess, protect myself from ransomware, but all this is going to really help with is recovering from a cyber attack, not actually stopping one from happening. So as far as Windows is concerned, this is pretty much full protection, and I even went into the device security tab here and I enabled the core isolation feature for the memes. Now, if I go ahead and I scan this evil.bat file with Windows Defender, or Microsoft Defender rather, I forgot that they renamed it, you can see that we get a clean bill of health. And I really didn't even have to do that manual scan since Microsoft scans everything that's on a Windows 11 machine anyway, at least batch files and EXEs and stuff like that. I can even scan it with Malwarebytes because I just decided to install Malwarebytes to this VM too for the memes. So you can see that the custom scan is in progress here. Scan is complete. Nothing malicious has been found with this evil.bat file. I actually plugged this evil bat file into virustotal.com earlier, and only 2 out of 61 anti-malware solutions were able to detect it. This is the reason why security professionals who don't actually make money from selling this snake oil software and aren't affiliated with any of these vendors are going to tell you that your antivirus really doesn't matter that much, or they might tell you that the best antivirus out there by far is common sense. You see, this malware doesn't take any coding or hacking expertise to use. It was created by an automated tool that can be found on GitHub, and if this was malware that someone actually wrote from scratch, it would probably be fully undetectable by all antivirus programs until a signature was created for it after a lot of damage had already been done. So let's see what this evil bat file actually looks like. All right, so we can see that this evil.bat file is calling on PowerShell with some additional flags to keep the window hidden and keep it from closing after it's done executing. But then we just have a bunch of what seems like complete gibberish being fed into PowerShell. And the reason this looks like gibberish is because it is base 64 encoded. So if we go ahead and decode it, now we get something that starts to be at least legible, but all of this source code is still scrunched together. So I'm going to reformat this, add a few comments to it, and then we'll go through the cleaner source code together. All right, so I've reformatted the code here, and I didn't bother with renaming the variables because there's only 8 of them, and I think it's pretty straightforward what all these variables represent. So this first part here is just defining the connection details for connecting back to our attacker's machine. So this is the IP address of the attacker's machine, and this is the port that we're going to be communicating over. Now, in a real attack scenario, this IP address would probably be a public one and not just a local one, unless the attacker is actually on site attacking this machine over the LAN. And this port might also be different. Again, it's probably going to be something that isn't going to raise any alarms on network security equipment. It's probably going to be a more commonly used port so that this malicious traffic is going to blend in better with the legitimate traffic that's coming out of and going into the organization. So in section 2 here, we are establishing a TCP socket for the communications, and this represents our data stream that's coming from our attacker's machine. So here we're initializing a buffer to store incoming data up to 65,535 bytes at a time. And these next two lines create a prompt string to send back to the attacker. It's going to say PS for PowerShell, since that's the kind of shell that this malware is going to give us. And it's going to tell the attacker what the current path, the current working directory is that the malware is executed in first, and then it's going to give whatever directory the attacker decides to switch to after that in the prompt. Now, this while statement here is basically the beginning of the main execution loop of the malware. So data is read from the attacker, which is going to be commands for the target machine to execute. And this first line after the while loop is converting the received data from bytes into readable strings. And then inside of this try-catch block, we have an invoke expression which executes the command from the attacker on the target machine. And then this later half of the statement captures both the output and any errors from the executed command as a string. If there's any errors, then they get caught in here in the catch block, and the attacker gets a message on their machine that something went wrong with the execution of that command on the target machine. Now, in the next few lines here, the prompt string along with the output of any executed commands is going to send back to the attacker. And then finally, this flush command ensures that all data is being sent out immediately. Okay, so here on the attacker side, I've already started a handler through MSF console. So basically what this is doing is it's listening for an incoming connection on this IP address. Again, this is just the local IP address of this Kali Linux machine, and this would only work if it's going to be on the same LAN as the victim machine. Otherwise, it would have to be a public IP address. And this is the port that it's going to be listening for the connection over. So once this connection is made, the handler is then going to drop us into a shell that will allow us to have full control over the victim's machine, or at least it's going to give us whatever privileges that the bat file is run as. So it's basically going to give us user privileges, but you would escalate to root through some other kind of exploit after the fact so that you really get full control over the machine. Okay, so we'll switch over here to the victim's device real quick, and we'll keep the terminal on Kali Linux visible. So this is the evil bat file that I copied into the documents folder. And I'm just going to go ahead and initialize it by clicking on it. And they've run that little bat file. A terminal window pops up quickly on the victim's machine and then closes, and boom. Now you can see that I've got the shell prompt here with PS, and then it's got the file path for where it was executed, just like we saw in the technical breakdown of that reverse shell. So from here, I can do anything on this machine remotely as if I was sitting right in front of the machine, just using PowerShell. You know, I can get sysinfo, and actually I think that pops up a GUI window. Let's do system info. So this is some analysis that somebody might do on your machine so that they can get more information about it, try to figure out what additional exploits it's going to be vulnerable to for things like escalating privilege, like I mentioned earlier. And from here, I could download any file from the victim's machine to Kali Linux. I could upload any file from Kali Linux to the victim's machine. I could encrypt their hard drive, or better yet, I'm going to use this reverse shell to run some even more sinister malware like the Hackermans that you've seen on TV. This is a shell script that I cooked up earlier, and what it's going to do is it's going to give the user of our victim's machine a better appreciation for Shrek. So the first thing I'm going to do is I'm going to make the target machine download this shell script from termbin. And actually, let me go ahead and switch back to this view so you guys can see what's going on the victim's machine as well. So we're going to make them download this to their documents folder, and as you can see, this runme.ps1 file has appeared. So let's go ahead and runme.ps1 and see what happens. So we've got our desktop background changed to this wonderful Shrek looking over Windows XP.
Somebody
Here we've got some drums that's going to play. So that we don't all get brain damage from Smash Mouth. But there you go. Things are all ogre for this machine. It's now part of Shrek's Swamp, and whoever executed this batch script that they probably found on a Mongolian basket weaving forum should stop using computers and consider becoming Amish. If you enjoyed this video, please like and share it to hack the algorithm.